Now we are going to look at number 21. Now number 21 goes like this: the end of term test scores of 100 students. So you know that the number of students, if you add all of them, they must equal to 100. Scores of 100 students were recorded as shown in the table below. So the table has the ranges for the scores. That is from 30 to 39, 40 to 49, 50 to 59. So you can see it has a class width of 10. Class width of 10, 10, 10. Then you have the number of students, that is our frequency, 8, 10, 28, 32, 12, 10. So the question requires to calculate the model class. Now, model class is one that has the highest frequency. So the one that has the highest frequency of 32, that class is from 60 all the way to 69. That is our model class. Then it also requires us to calculate the median of the scores. So the median here, before we calculate the median, we know that the median equals to L plus, that is n over 2 minus that is the cumulative frequency, then over the frequency of the class, then multiplied by the class width. Now, in this case, you have to find the value of n, and the value of n is how many students? 100 students. But before we do that, we have to find another column of cumulative frequency, whereby here it is 8, 8 plus 10 is 18, 18 plus 28 gives us 46, 46 plus 32 gives us 78, 78 plus 12 gives us 90, then 90 plus 10 gives us 100. There are 100 students in total. So in this case, we are going to have L. L is the lower class boundary of the median class. So 50, so 100 divided by 2, it gives us 50. So 50 is going to lie in this class here. And the lower class boundary of this class of 60, it is 59.5 plus n over 2, that is 100 over 2, gives us 50 minus the cumulative frequency above the median class. That's the cumulative frequency before, that is 46, over the frequency of that median class now, which is going to be 32, then multiply by the class boundary, which is 10. Now, if you carry out this mathematics very well using your calculator, you're going to end up with 60.75, and this one is the median score for this particular class or this particular test. Now, next, you've been provided with a grid on which you have to draw a histogram. Now, in drawing a histogram, we have those who draw a histogram using frequency on the y-axis against the upper class boundaries. Then you have those who draw a histogram using the frequency density against the upper class boundaries. Now, if you use the ones for frequency density, it means that you need to have another column for frequency density. So you can have a column for frequency density, so that the first one, if you take 8, so frequency density, you know it is going to be the frequency over the class width. So it's going to be 8 divided by 10, which is 0.8. The next one, 10 divided by 10, it is 1.0. Next one, 28 divided by 10, it will be 2.8. Then after that, 2.8 have 3.2. After that, have 1.2. Then the last one have 1.0. So those are frequency densities. So you have those who plot frequency densities against upper class boundaries, and those who plot frequencies against upper class boundary. And I'm going to show you how to do all of them. Now, for frequency density, this one is mostly used when the class width between the class width is not equal. Like you can have from 30 to 39, 40 to 45. Those one will not have an equal class width. So for those one, frequency density will do it very fine. But still, we are going to use both of them to try and draw a histogram for both of these. So don't mind about my grid. It's a bit skewed due to printing and photocopying issues, but I'll try my very best to make sure that you are able to understand everything that is going on here. So we are going to have the y-axis. Then on this side, it is not a must you break, but you can break if you want to. On this side is where you are going to have the x-axis that is going to accommodate our upper class boundaries. So on the x-axis, we are going to place here the upper class boundaries. Upper class boundaries. That is of our scores. Upper class boundary of our scores. Now, I look at here, we have the lower class boundary, class limit as 30. So the boundary here is going to be 29.5. After 10, that is 2 squares, because you know our scale, you don't need too many. After 2 squares, you are going to have 39.5. Go also after another 2 squares, we'll have 49.5. After another 2 squares, we'll have 59.5. After another 2 squares, have 69.5. After another 2 squares, have 79.5. Then after another 2 squares, you'll have 89.5. The highest score here is 89, so it is 89.5. That is the upper class boundary. So on the y-axis, you can either use frequency or frequency density. So I'm going to include all of them. So I'm going to do frequency density, so that here I'll have 0. Here I'll have, I'm going to move 2, 2, 2, 2, so that I might cover more ground. So after 2, here I'll have 1. After 2, I'll have 2. After 2, I'll have 3. Then after 2, I'll have 4, like that. That is for someone who is using frequency density. Now, we know that the first 30, that is 29.9 to 39.5, has a frequency density of 0.8. So we go up to where you have 0.8, is at this particular place, using your ruler very well. We draw the histogram at this particular place, and the histogram should be very visible. So using your ruler, we'll draw that histogram. That is for the first one. The next, we have the class of 39.5 to 49.5. It goes to 10. 10, it is 1. So the next class will go up to 1. Next class will go up to 1. The next class will go up to 2.8. So we go up to 2.8, just 2 boxes shy of 3. That particular place. Now it is good that you use a ruler at this particular place, so that you don't make any mistake. I'll do it freehand, but it is good that you use a ruler. Then after 2.8, you have 3.2. Next one goes 3.2. That is 2 boxes after 3. 2 boxes after 3. That is for 3.2. Then the next one is 1.2. 1.2. That is 2 boxes after 1. Like that. Then the next one is going to be 1. That is exactly on 1. And this one constitutes what you call a histogram. Then you can shade using very straight lines. And a ruler is very important when carrying out this one, so that we don't make mistakes A ruler is very important so that you don't make any mistake. Just continue and try to make sure that it is appearing very well. No detail is left out. You want to make it very conspicuous so that a person who is even at far distance can be able to see that that one is actually a histogram. This one is now a complete histogram. And this is for a person who used frequency density to plot. What if a person who used frequency to plot this particular histogram? Now, if a student uses frequency, we can see that the frequency, the highest is 32, the lowest is 8. So we can start to label our frequencies as we go up. We can look for a very convenient scale. You can say this one is 0, 5, 0, 5, 10, 15, 20, as we go. You can have 0, 5, 10, 15, 20, 25, 30, 35, 40. That is for a person who used frequency to plot this particular histogram. Now, if you use frequency, you plot the class boundary 29 to 39.5 against 8 at this particular place. So it will still be the same histogram, but this one now you have used frequency against the upper class boundaries. Then use the histogram to determine the number of students who scored between 71.5 and 76.5. Now, 71.5 is just one box after 69.5. You know that each box is 1, 1, 1, 1, 1. So from 71.5 all the way up to 76.5, there is 1, 2, 3, 4, 5 squares. So for the person who used frequency density, you are going to take 5 small squares, that is from 71.5 to 76.5, 5 times the frequency density of that particular histogram, which is 1.2, and this one is going to give us 6 students. 6 students. But for a student who plotted frequency, that is frequency against upper class boundaries, we will count the squares here are 5 of them from 71.5 to 76.5. There are 5. Then multiply by the frequency of that particular histogram or that particular bar, which is 12. Then divided by the class width. The class width is 10, and this one still will give us 6 students. So any of those will garner you marks for this particular question.